Hey everybody, in today's episode we're going to continue our discussion of basic differentiation rules with a look at the quotient rule and the product rule. Before we talk about the product rule, I want to point out an addition to our derivative notation. So we've seen prior that the f prime of x equals d dx of f of x, and y prime are all ways of representing a derivative. Another way that is quite common is this notation dy dx. So if your function is defined as y, you're taking the derivative of y with respect to the variable x. Now let's take a look at the product rule. If our function can be defined as a product of two functions in terms of x, then the derivative is the first function times the derivative of the second plus the derivative of the first function times the second. Now let's take a look at a couple product rule examples. In our first example, we have the product of two factors, and the first 2x minus 3x squared we'll look at as f of x, and 1 minus 2x we'll think of as g of x. So our derivative is going to be the first factor, 2x minus 3x squared, times the derivative of the second. So 1 minus 2x, the derivative of that is negative 2. Then we add the derivative of the first factor, which is negative 6. Oh, it's 2 minus 6x. And then times the second factor, 1 minus 2x. So we're going to have to FOIL that. Let's go ahead and distribute the negative 2. So that's negative 4x plus 6x squared. And then we're going to FOIL this, so that's 2 minus 4x minus 6x plus 12x squared. Now we'll combine our like terms. So we have a negative 4x and a negative 4x and a negative 6x. Those will combine to negative 14x. But let's put our 12x squared and our 6x first. So that's 18x squared. And then we said negative 4x, negative 6. That's negative minus 14x. And we have a constant in there. Yeah, there was a 2. So there's our derivative. In our second example, we have 2x cubed times cosine of x. So what's our derivative going to be? It's going to be the first factor, which is 2x cubed, times the derivative of the second. So that's minus sine x. The derivative of cosine x is minus sine x. And then it's going to be the derivative of the first factor. So 2x cubed is going to be 6x squared times the second factor. So that's going to be, let's put the positive term first, 6x squared cosine x minus 2x cubed times sine x. Next, we're going to talk about the quotient rule. And the quotient rule is used when our function is a quotient of two expressions in terms of x. So if you have a rational function with a numerator in terms of x and a denominator in terms of x, you may need to use the quotient rule. And here it is. The denominator comes first in both the denominator and the numerator, so we put the g of x in both places, square the g of x, and then multiply in the numerator, multiply g of x by f prime of x. And then we switch the f of x and g of x, so we subtract f of x times g prime of x. Now let's look at some examples of the quotient rule. In our first case, we have a rational function 3x plus 4 over x squared plus 1. So what's the derivative going to be? Well, I start by putting the denominator of f of x first. So I'm going to put x squared plus 1. And I'm also going to put x squared plus 1 in the denominator of my derivative and square it. So now, since I have g of x first, then that's going to be times f prime of x. So that's going to be times 3. Now we subtract and we put f of x first, the numerator of our function, and we multiply it by the derivative of the denominator. 2x is the derivative of x squared plus 1. All right, let's simplify that. So that's going to be 3x squared plus 3 minus 6x squared minus 8x all over. And finally, let's combine our like terms. Our like terms, the x squared term, that's going to be minus 3x squared. Our x term minus 8x, and then a plus 3 all over x squared plus 1 squared. For our next example, I will change colors. It's getting a little crowded here. The derivative of 2x plus 1 over x minus 5. So I'm going to start out with g of x, or the denominator of my function, in the denominator and in the numerator. So now I multiply that by the derivative of the numerator. Derivative of 2x plus 1 is 2. Now I do f of x, the 2x plus 1, times the derivative of the denominator. In this case, that's just 1. And resimplify. So it's going to be 2x minus 10 minus 2x minus 1 over x minus 5 squared. And so the 2x's cancel, and that's going to be negative 11 over x minus 5 squared. Finally, an idea that goes along with the quotient rule is to rewrite. Make sure you rewrite the function, fully simplify it before resorting to the quotient rule. I'm pretty sure the quotient rule is nobody's favorite rule. So a lot of times you'll see a rational function or a fraction and you will jump in thinking you need to use the quotient rule, but there's often an easier way. So let's work through some of these examples. We have a couple of fraction examples here. And our first one, we can rewrite this first function as 1/3 times x squared plus 2x. Now that makes finding the derivative fairly easy work. So the derivative over here is then going to be 1/3 times the derivative of x squared, which is 2x, plus the derivative of 2x, which is 2. And you can leave it just like that. In this second example, if we factor out the 3/5 and write this as 3/5 x to the 7th, then we can use the power rule to find the derivative. So 7 times 3/5, that's 21/5. X, and then the exponent goes down 1. Okay, finally a couple more simplifying or rewriting examples. You can see from this first one that we could rewrite it as, let's see, -5. We have a common factor, x, in the numerator. Let's take the x out, and that leaves us with 2 minus 5x squared over 3x. Well, those are going to cancel out. And so that gives us -5 times 2 minus 5x squared over 3, which we can write as -5/3 times 2 minus 5x squared Now I'm going to change colors here for the derivative. We're getting a little crowded here. So the derivative is going to be equal to negative 5/3 times the derivative of 2 minus 5x squared. Well, that's 0 minus 10x, so negative 10x. And that simplifies to 50x over 3. Now, one more example. In this problem, 2x over 5x to the third, we can pull out the coefficient, 2/5, and then x divided by x to the third, that's going to be x to the negative 2. X to the 1 divided by x to the 3, that's 1 minus 3, or negative 2. Let's go ahead and write the derivative over here in red just to be consistent on this slide. So now we would use the power rule, negative 2 times 2/5, that's negative 4/5. And then we're going to reduce the power by 1. And if you like, you can write that as negative 4 over 5x cubed.